I am an avatar organized by Dr. Alemi to describe the calculation of total effect in step 2 of the DEMI algorithm. The knowledge base stores co-occurrence counts for every pair of medical concepts. These 4 counts, A, B, C, and D, form a 2x2 contingency table. Cell A counts patients who have the feature and the outcome. Cell B counts those with the feature but not the outcome. Cell C counts those without the feature but with the outcome. Cell D counts those with neither. The raw odds ratio is A times D divided by B times C, and the total effect is the natural log of that ratio. 2 problems arise in real data. 0 cells cause division by 0 or multiplication by 0, and small samples produce inflated odds ratios because D tends to be enormous. DEMI has a specific correction for every situation. With all cells positive and both sample sizes of 30 or more, we use the standard formula. Odds ratio equals A times D divided by B times C. In this example, having hypertension gives an odds ratio of 3.93 for sertraline response. When cell A is 0, the feature never co-occurs with the outcome, and the raw formula fails because it multiplies by 0. This rule applies regardless of sample size. If B is also 0, meaning the feature never appears in the data at all, we use 1 divided by the quantity C plus 1. If B is positive, we use 1 divided by the minimum of B and C. This captures a conservative protective signal. The only completely unresolvable case is when both A and C are 0, meaning the outcome was never observed in the data at all. That row is excluded from the algorithm entirely. When cell B is 0 but A is positive and sample sizes are 30 or more, we apply a Laplace plus 1 correction to the 0 cell. If B is 0, it means no one with the feature failed to get the outcome, a very strong positive association. The odds ratio becomes A plus C divided by 1. If C is also 0, the outcome never occurs without the feature, highly specific. The odds ratio becomes A plus B divided by 1. In the rare case where both B and C are 0, meaning perfect co-occurrence, we estimate the odds ratio as a plus 1. This is conservative and finite. With small samples, the enormous cell D dominates the numerator and inflates the odds ratio far beyond what the small values of A and B can support. In this example, the raw odds ratio is 4,286, which is meaningless. The fix is to estimate D from each observed binomial sample separately. From the exposed sample, we solve for D star by setting the case rate equal in both halves. D1 star equals B times the quantity A plus B divided by A, giving 23.3. This yields OR1 equal to A plus B over C, which is 2.0. Then from the case sample, we solve similarly. D2 star equals C times the quantity A plus C divided by A, giving 13.3. This yields OR2 equal to A plus C over B, which is 1.14. Because the raw odds ratio is greater than or equal to 1, we take the maximum of OR1 and OR2, giving a final adjusted odds ratio of 2.0, a reasonable estimate, versus the inflated 4,286. If the raw odds ratio were less than 1, we would take the minimum instead. When you have both a small sample and a 0 cell, the 0 cell rule always wins. You always check for 0 cells first, regardless of sample size. The sample size adjustment using the 2 D star estimates only activates when all 4 cells are positive. This consistent ordering is critical. It ensures the algorithm never tries to apply both corrections at once and handles every possible combination of conditions unambiguously. Let me walk through the complete set of edge cases. If cell A equals 0 and cell C equals 0, exclude the row. There are no cases in the data and no association can be estimated. If A is 0 and B is also 0, use 1 divided by C plus 1. If A is 0 but B is positive, use 1 divided by the minimum of B and C. If both B and C are 0 but A is positive, use A plus 1. This is perfect association. If B is 0 and C is positive, use A plus C divided by B plus 1. If B is positive and C is 0, use A plus B divided by C plus 1. When all cells are positive and both sample sizes are 30 or more, use the standard formula, A times D divided by B times C. Finally, when all cells are positive but one or both sample sizes are small, use either the maximum or minimum of the 2 adjusted odds ratios derived from the binomial samples.